Lesson number 2, daily summary. In this lesson, we tackle our first word problems and see a powerful technique for starting word problems. Pick a random number to figure out how to set up your expressions/equations. Number 1. Sometimes when we are asked to write an algebraic expression to describe a situation, we may not know where to begin. Many times we know how to do the problem using numbers, but do not know how to create an algebraic expression. Let's see how we can use numbers to find a pattern so that we can write an algebraic expression. First, a quick detour. Number 2, a quantity is anything that can be counted or measured like length, weight, area, number, volume, and time. A unit is a fundamental amount of some quantity. So for example, the quantity length could be measured in the unit word inches. That's not the only unit that you could use to measure length. You could measure length in feet or meters or yards, miles, lots and lots of different unit words for length. Similarly, the quantity word weight could be measured in pounds, but you could also measure weight in ounces or in tons or in many other different units. And in terms of, let's just do this one more, number, we could be counting cars. So the number of cars, the quantity word is number and the unit word is cars. If you have a quantity word and a unit word, and you don't know which is which, put a random number in front of each word. The word that makes sense with the number in front of it is a unit. For example, of the words time and hours, which is a unit and which is a quantity? So the suggestion here is that you put a number in front of both words. I'll make up the number 7. 7 time, 7 hours. The one of those phrases that makes sense is the one that contains a unit word. So which one of these is a unit? It's hours. Hours is a unit, and that means by default time is a quantity word. So just a really quick way to tell which is which if you're not 100% sure. Number 3, Lee went to the store and bought books and CDs. Books cost $10 each and CDs cost $15 each. She bought 12 items altogether and spent $155 in total. We will find out how many books Lee bought and how many CDs Lee bought by following the process that follows. We could let X equal the number of books Lee bought, or we could let X equal the number of CDs Lee bought. I want to point out here, in each of these definitions, both of which are good, there is a quantity word. I'll underline here the quantity word in green, quantity word, and there is a unit word, number of books. Books is a unit. Number of CDs. CDs is a unit. So both of those definitions are good. Every variable definition, sorry, I'm skipping something, but we can't let X equal books. X equal books is an incomplete definition, and we can't let X equal CDs because those definitions don't include quantity words. When you're talking about the books, you need to describe a quantity that you're calculating or counting for those books. When you say the books, is it the number of pages in the books? Is it the weight of the books? No, it's none of the above. It's number of books. But you got to be really clear because there are a lot of number things you could associate with the books. Specifically, the only one we care about for this problem is how many, the number of books. So just be clear when you're making a definition this semester, every variable definition has to contain a quantity word and a unit word. There's no such thing as a one-word variable definition in this course. So we will commit to letting X equal the number of books Lee bought. Circled there is the quantity word, number. Books is the unit. Here's the original problem. Lee went to the store and bought books and CDs, and books cost $10 each and CDs cost $15 each. She bought 12 items altogether and spent $155 in total. Okay, so let's start answering questions about that setup. In terms of X, write an expression for the number of CDs Lee bought. Number of CDs Lee bought. Okay, there's going to be some formula here with X in it. Some lucky few of you might already be able to just figure out right away what the expression is. That is wonderful. More power to you. But for the rest of us, we just make up a number. Suppose that, for example, I say X equals 2. 2 what? 2 books, because that's what X represents, the number of books. If Lee bought 2 books, can we then answer this question? How many CDs did Lee buy? Yeah, you bet. There's 4 different numbers up here in this problem. There's the cost per book, there's the cost per CD, there's the 12 items altogether, and there's the $155 in total. Of those 4 items, only one of them makes any difference for answering this question here, the number of CDs that Lee bought. Which one is it? Well, hopefully you see that the dollar amounts have nothing to do with how many CDs Lee bought. Lee bought 12 items altogether, and if there are 2 books, then the rest of them must be CDs, right? So if you bought 2 books, then the other 10 must be CDs. Number of CDs equals 10. But we got to make sure we understand what calculation we did. We did some arithmetic to calculate that 10, and the arithmetic was so basic we might not even be aware that we did it. But how did we calculate 10? We started with the number 2, and we somehow magically came up with the number 10. Well, we know there were 12 items altogether, and 2 of those items were books. And if you subtract off those 2 books from the 12 items, you are left with 10 CDs. That's the calculation. It's 12 minus 2. Okay, so let's answer the question now. Instead of 12 minus 2, it's really 12 minus the number that we happen to make up, which is really called x. So the answer to this problem here is 12 minus x. Nothing more and nothing less. Doesn't include any of the dollar amounts, only includes the 12 and the x, and it's got to be 12 minus x, not x minus 12. Some other problem, it could be x minus 12. So there's nothing to memorize here. It's really just about pick a random number, do the problem for that number, and then see if you can generalize and bring things back to the more abstract x expressions. Okay, part B, in terms of x, write an expression for the amount of money Lee spent on books in dollars. Amount of money Lee spent on books. Okay, I don't know, let's see. If, for example, x is equal to 2 books again, then how much money did Lee spend on books? Well, take a look at those 4 yellow highlighted numbers. One of them is relevant to this. The other 3 are completely irrelevant to this part of the question. How much did we spend on books altogether? Well, the only number that matters is this one here, right? $10 each. So if it's $10 each and you bought 2 of them, then you spent 20 bucks. But again, okay, so then the amount spent, it is 20, but we got to really slow that down and make sure we understand what arithmetic calculation we did to get 20. Well, we took the $10 per book and we multiplied it by the 2 books, yeah? 10 times 2. And so it's the same process as before. We just replaced the specific 2 that we picked with the more general x, right? This 2 was something we made up, but really it's going to become an x. So the answer to this problem right here is not 10 times 2, but 10 times x. And I want to point out, so that's it. And again, the goal of this pick a number technique is for us to see that problems are almost always much, much simpler if you just pick specific numbers. And then oftentimes you can take the insights you develop by doing the specific arithmetic, you can take them and apply them to the more general algebraic expressions that you're trying to create. I do want to point out at this moment that there is a pattern here, I guess a format for this answer. That $10 was the cost per book. And then that x was the number of books. And that's basically the formula for the total cost you spend on books. It's not a formula to be memorized. We just reasoned our way to it very easily. But I just point out the pattern because it's going to help us in part C. In terms of x, write an expression for the amount of money Lee spent on CDs in dollars. Well, it's the same format, right? It's going to be the cost per CD times the number of CDs. Okay, so let's fill in the blanks here. What is the cost per CD? Well, it's one of our 4 highlighted numbers. CDs cost $15 each, so there you go. Cost per CD, that's 15 times. Number of CDs, really common wrong answer here is to put x. Say, oh, 10x up above for books, 15x for CDs. No, x is the number of books, and that's important for part B because part B asks for the total cost of the books. But what we need to fill in this blank right here is something that represents the number of CDs. And it's not x. X is not the number of CDs. So we just have to look earlier in this problem. We already calculated an expression for the number of CDs. Do you see it? It's this right here. Number of CDs is 12 minus x. That's what's going in this blank. 12 minus x. Because 12 minus x has more than one term, it is mandatory to put parentheses there. So that green pattern still holds. Number of CDs times cost per CD. Same as we did up above with the books in part B. And then just make sure you don't copy the x. It's 12 minus x. Okay, part D. In terms of x, write an expression for the amount of money Lee spent altogether on books and CDs in dollars. Okay, I think that this is just a matter of adding up a couple of answers we've already got. Total amount we spent on books and CDs, that's the answer to B, plus the answer to C. So those two things added together, that's it. Part E, Lee spent $155 on books and CDs using the expression you created in Part D, set up and solve an equation for X. So we will take our expression from Part D and just make it equal this 155, because after all, this thing is the total amount of money you spent. It represents the total amount you spent based on buying X books. And we're trying to make that equal the magic number 155. And you think about the original problem, right? Like Lee went to the store and bought books and CDs, and then the 4 highlighted numbers. Ultimately, the goal is the equation that we just wrote down, and we're going to solve the equation. But getting to the equation is a big part of this problem. I mean, really, like half the problem in terms of like points on a test or a quiz, roughly half of the problem is getting to the equation. Solving the equation, I think, is going to be pretty straightforward. But getting there, I just want to make sure you don't sell it short. It is a significant part of this problem. And it's complicated to get there just from the original problem here at the top of the page. It is really hard to get from that directly to the equation that we just created at the bottom in one fell swoop. This equation at the bottom was the goal. But we got there in pieces, and I think that's a reasonable way to get there, right? We just go piece by piece and eventually get to this more this complicated equation here. Okay, so let's solve the equation. 10x plus, we'll distribute the 15. That's 180 minus 15x equals 155. 10x minus 15x, that's negative 5x plus 180 equals 155. Let's subtract the 180 from both sides. So we get negative 35 there. And then divide both sides by negative 5. We get x equals 7. So x, remember, was the number of books. So that makes it number of books is 7. And then number of CDs was 12 minus x, right? That was the very first part we answered. So 12 minus 7 is 5. 5 CDs. And then as a quick check, books and CDs total 12 items altogether, which makes sense. Number 4, solving real-world problems involves creating equations that represent the problem accurately. In order to solve realistic problems, we must learn how to read the information given and translate this information into an algebra equation or equations. This takes lots of practice. The main thing to take away from what we did above is that if you don't know where to start, try picking some specific numbers to see if that gives you any insight. Keep this technique in mind as you work through the activities and also the homework. So just one last thing here, really highlighting. It is very tempting to just go directly from a given problem in an activity or in the homework to try to just immediately set up the equation. And it's possible you can get there without any of this intermediate stuff, without picking random numbers and kind of feeling your way out in the dark for a little while before you get to the equation. But unless you're 100% certain that you understand how to create the algebraic expressions just from the words, I strongly encourage you to use this number technique. And don't feel like you have to like graduate from this number technique at some point, like in this semester or even in a future class. Just keep using it. It's a really good technique. Really hard for most of us, myself included, to take all the words and just come up straight off the bat with an equation. But going piece by piece and using numbers to help can make a tough problem much more manageable.